questions from past exams last semester, and also I can go over your exam too from this semester. So I encourage you all to come, especially if you would like to do one of the makeups for next Friday. Thank you.
Okay, any question about SI pass? Yes.
Are there like any good times to do that? Because I mean, I work, especially so late.
Yeah, I'm also going to hold another review session next week. And if you guys can't make it to one of them, just shoot me an email and I can try to do a review activity for multiple sessions next week.
Okay, so for people who are watching at home, 5 of you, usually that I see the YouTube, video, the views on YouTube, and usually it's like 5 for each class, and we have lots of students that are absent. So for those of you that are watching this at home, what we talked about is SI pass sessions. And can you also guys send me, so these are like different from the one in syllabus and course schedule, right? These sessions, you said that you changed the hours?
I changed short of mine.
Okay, can you also send me an email so I post an announcement on Canvas too for students who are referring to course syllabus and schedule to know the changes in SI pass? Okay, so one thing that I want to mention before starting the lecture is that your next quiz originally was due this Friday, but since I'm going to have like extra tutoring sessions with myself, and we're going to have like makeup exam, and also I'm going to have like makeup quiz 3 for students who didn't do well on that. For all these reasons, I'm going to have the deadline for your next quiz the following Friday, 15th. Okay, so I'm going to write here, April 15th would be deadline for quiz 4. Okay, and I'm going to send an announcement on Canvas too, because I want you to first do your homework 12 to see the type of questions that you're going to see and practice more, and then also we have like more tutoring, and then you take the quiz. Okay, any objection to this? Anyone that wants the deadline be this week? Yes?
For the homework, do you think you can open the time a little bit longer? Because for me at least, it takes me a little bit longer than an hour because I like to go through my notes and make sure I'm actually doing it for the homework assignments. So would that be possible to open them up a little bit? Because I had to cram in like the last 4 questions of my homework assignment.
So the short answer is I'm not going to do that because you're supposed to study before taking the homework, okay? So you're supposed to go through the lectures after each session and study the materials, and then when you're taking the homework, it should, kind of like be a representative of your exam, okay? So you should already know how to solve the questions when you look at your homework questions. But as I said, I'm going to have those open book, open notes, so you can go back and check your answers, but you're not supposed to study per se when you're taking the homework. Does that make sense?
Yeah.
Okay, so that's why I tell students that don't wait for the last minute when I post the homework to do the homework, because you should use that time, the weekend that you have, to study for the course materials.
I feel like in that case, would you be willing to put the homework assignments due on Friday so we have the whole week to study the material?
So,
Because if that's the case, like for me, I'm a full-time worker and a full-time student, so I just kind of have to balance all of that, and I like to use the homework assignments as my study guide when I'm doing my review.
So when you- okay.
That's how I use this class.
Because it's a homework assignment, not a quiz.
Yeah, that's what it is. Because if you're going to put a quiz assignment at the end of, then I feel like it should be a quiz.
Okay. So I see what the confusion is, but okay. Calm down, everyone. It's just like a chemistry class. It's nothing more. Okay. So when you want to study for chemistry, you have your slides, and then you go through that, and that is how you study, okay? So you don't need your homework to study for the class. You need your lecture slides, and then your book, as I recommended at the beginning of the semester, and you need those materials to study. So this is the difference between studying and do the homework assignment. So homework assignment is not studying. Studying means that each session, when I tell you what is a chemical reaction, you go to the lecture, not this. I asked you all to fill out this questionnaire that I sent on Canvas in one announcement, and only 11 people fill that out. And I told you don't have to put your name if you're not comfortable everyone seeing that. You can just put your initial, or like your, for instance, you can put only L that represents Lida, or something that you should put something, that it counts, But, as I said, 11 people fill that out, and we have like 59 students as of right now, they are failing this class. And I say that based on exam 2 results, okay? So if you're failing exam 2, it's highly probable that you're failing exam 3, because if you didn't learn the previous materials, you cannot do well on the next exam and also final. So I encourage you to, so right now I just scheduled these tutoring sessions, but if you cannot make any of these, just like email me so I figure out something, or go to your SI Pass sessions, or like go to tutoring at library. And here, based on 11 students that fill this out, based on the times that they were available, I scheduled these times for tutoring with myself, that I'm going to go through the materials and solve more examples and make sure that, prepare you for your makeup exam 2 and then quiz 3. Any questions? Good? Okay. If no question, I'm going to continue on. You say, okay, transformation of one or more substances into different substances. You don't need a multiple choice question to study.
I guess the disconnection, at least for me, is the questions on the homework assignments is what helps me figure out what I need to work on. And so if I'm only giving one shot in an hour timeline to do those questions, and I don't really actually get the materials I need to learn to figure out to study on, because there's a lot in all the chapters, and while yes, I do go through all the terms and stuff like that, I'm not exactly sure what I need to work on. And I like the fact that there are specific example questions that are on the homework assignments that show up on both quizzes and the exams, because it's consistent with you, that don't necessarily translate exactly in the book. So that's just where I'm at personally, is because I see homework as a assistance to my study, not necessarily as I have to study to do my homework, because I see quizzes like that.
Okay. So just let me ask you guys this. For your exam 2, I posted 6 different versions of last year or last semester. Makeup quizzes, makeup exams, and all that with solutions. How many of you studied those before your exam 2? Really? Okay, so some of you, or most of you, saw some of the questions were exactly, from those. So, I posted so many different resources for you all. But if the only concern is having more time for homeworks and posting them on Friday, I'll do that. But even when I post the homework on Sunday, every day I go check how many students took it. And for the last homework, even until Monday that I checked, nobody took the homework. So if you're claiming, if I increase the time and post it Friday, actually I was just writing your next homework during my office hour for my other class today. So I just posted right now, right after the class, for you all to have more time, if that solves the issue, okay? But the issue is that you should study. and study anything that I write in this slide, I'm going to ask you in the exam. As simple as that. So it's not like, and then homework questions are from the things that I talked about in the class. And I see students still don't know the difference between metals and non-metals. And I had periodic table every single session. When I started talking about elements, I was like, and then I started, talking about each of these. Lithium, sodium, potassium, remember this would be useful. And then next session, I would say, do you remember what was alkali metals? And then people would laugh or don't know the answer. And then I talked about 3 different elements at the time, and then talked about which ones are like metalloids, these zigzag, remember, these are like non-metals. So if you're claiming that, the issue with some of you struggling is because how I teach, I take the criticism, okay, I'm working on myself, okay, I give you more time for homework assignments, and I'm going to post them sooner, even I posted today, okay? So you have more time to work on them. But the way to study is to go through each lecture that I teach you and read the sentence, make sure it makes sense, repeat it to yourself, okay? And make sure you understand it. And this is how to study, okay? But again, I don't want you to be angry at me, or like be upset at me. As I said, and you can ask your friends last semester too. I was just like writing makeup exams for them. I was just like proctoring exams 7 a.m. to 7 p.m. every day. And then accommodating everyone. And I gave them so many extra credit opportunities that this semester I implemented those in open book, open notes, homeworks, and quizzes, right? And as long as you want to succeed in my class, as I said, I just like put all I have in my classes. So there is no need to be upset or angry at me, okay? I make sure that, I take your suggestions and implement those, okay? So I'm going to post the homeworks and quizzes sooner, give you more time. Maybe that is how you want to study. But again, the reason I give you 1 hour is that you're supposed to study beforehand by going to each lecture, okay? Any questions? And you don't have to be afraid. I had like students in my 275 class that they were like making a suggestion, and then after class they were like, I didn't mean to, criticize you. I'm like, I welcome criticism, okay? And just welcome to communicate your ideas with me. And I try my best to be more clear and do my best to make sure every one of you succeed, okay? So just don't be afraid to talk with me, okay? Yes?
Did you put the extra credit that if some people got it from SIPass and stuff already with the exam? Or did you already upload that onto Canvas? I just don't know if I saw it.
Okay, the question is about SIPass tutoring. I implemented those before putting your midterm grades on Vandalweb. But for your final exam, what I'm going to do, I get an Excel sheet from Samantha, the SIPass coordinator, and I count, the sessions that each student went, and then add them before putting your grade from Canvas to Vandalweb. But if I do it each session, it would be super difficult for me to keep track of, but you're going to see the increase on Vandalweb. But I implement tutoring sessions that you have with myself or like extra credit opportunities in the class, I implement them immediately. But for SIPass and tutoring, I do at the end of the semester. Yes?
So will they be added to like our exam scores, or will they be like their own thing?
It would be like, for instance, if you see like your total score in Vandalweb, in Canvas, you see like, for instance, 78%, and then you went like to 4 sessions of SIPass, I add that to that grade, and then it would be 80%, so I put B in Vandalweb. Does that make sense? So it goes towards your final grade. Okay? Any other questions? So, reviewing the previous materials. And this session, I'm going to solve some problems to prepare you for like your next homework and also make sure you understand the material as well. So can anyone tell me, while I drink some water, it has been like a stressful session for me. I'm being attacked. So what is a chemical reaction while I do this?
The transformation of one or more substances into different substances.
Okay. So if I tell you, is the following statement true or false? A chemical reaction is transformation of one or more substances to a substance in liquid phase. True or false? False, because not necessarily liquid. We had like reactions that there is a solid or gas being formed, okay? And if I tell you, let me write this. So if I give you this, CH4 plus O2 gives CO2 plus H2O plus heat. I ask you what type of reaction this is. Combustion, right? Why? You see heat, yes. What else?
Carbon dioxide.
So carbon dioxide, yes, because it's an oxygen-containing species that is being generated. And some students are confused when I use a species. So a species is like one type or kind of thing, right? So here, each of these compounds that you see here, we refer as a species, okay? So that's what we mean, when we say species, okay? So carbon dioxide is a species. But specifically because you have like elemental oxygen here, when a compound reacts with elemental oxygen and then it produces oxygen containing a species plus heat, we call this combustion reaction, okay? And we had different types of reactions. So again, go through the slides that we talk about these things and study them. What was precipitation reaction? Can anyone tell me what is a precipitation reaction?
Where two aqueous solutions react and form a solid.
Exactly. Formation of a solid upon reaction of two aqueous solutions. So if you have liquid plus liquid giving solid, for instance, that is not a precipitation reaction. You should have two aqueous, okay? Anyway, example. And just kind of briefly mention, what was limiting reactant, what was theoretical yield, what was actual yield, what was percent yield. Can anyone give me these definitions? And again, you don't need a homework problem to say which of the following is a limiting reactant, just by looking at our product. So here, if I tell you, that I have, 0 eggs, right? How many pancakes I have? Nothing, right? So this reactant, the eggs are limiting my reaction, okay? Or if I have 1 cup of flour and then I have 1 egg, right? Based on my recipe, I should have 2 eggs. Can you guess which one is my limiting reactant? Eggs, right? Because it's less than what it should be based on my recipe. So it's limiting my reactant and it would be consumed completely. The pancake example, this is our recipe. Okay, so you give me the recipe and then I feel lazy, I don't make any pancake. And then you say, what is your actual yield? I say, unfortunately, 0. I didn't make any. Or maybe I bake some pancakes, I drop all of them. Again, I don't have any pancakes. So actual yield is the actual amount of product that is produced in the reaction. Here, let me just erase these things. This is my recipe, okay? And I tell you, I have 1 cup of, 1 cup, if I can just spell it, 1 cup of flour, and I have 1 eggs. And let's not worry about baking powder. And I tell you how much pancakes I can make. What do you think? So if I ask you, and I may give you in your homework, I say I have, I give you the recipe, and I tell you I have 1 cup of flour and 1 egg. What is the maximum number of pancakes I can make? What is the maximum number of pancakes we can make? So what you do is that for each of these, you do the calculation. So if I have 1 cup of flour, okay, if you just consider this, imagining that we have everything else we need, how many pancakes you can make? 5, right? Because you're just following your recipe, just considering we have everything else that we need. Now, if I tell you I have 1 egg, based on 1 egg, how many pancakes you can make? 2.5, half of it, right? Because you kind of cut all your recipe, 2.5 pancakes. Now I tell you, I have 1 cup of flour, 1 egg. What is the maximum number of pancakes that I can make? 2.5, right? Although theoretically, so when you look at like these numbers, you might be tempted to say 5 pancakes, but we don't have ingredients for that, right? So these eggs, or like this egg rather, is limiting my cooking abilities, I guess, or like the number of pancakes that I can make. So that is limiting reactant. So in questions that I ask you in exam, when I tell you what is the maximum amount of product that can be obtained, you should remember at this slide, you should be able to know these things, okay? So can anyone tell me what is limiting reactant? What is it? Yes, so limiting reactant or limiting reagent, as you see from the name, is completely consumed in a chemical reaction. It basically limits the production of, okay? And then remember, yield is your product. And in your exam, if you have like 2 or more products, I specify which one we mean, okay? So you don't have to worry about it. So yield is product, remember that. And theoretical yield is the amount of product that can be produced, that can be obtained from limiting reactant, okay? The amount of product that can be made in a chemical reaction based on the amount of limiting reactant. And then actual yield, again, remembering, okay? And percent yield is actual yield divided by theoretical yield multiplied by 100%. Are we good with these definitions? And again, don't be afraid. I know that it was some tension in the class, but I'm still nice. I tried my best to be nice, and then understanding, approachable, all the things that I claim I am. So if you have any questions, just ask me. And as I mentioned, I welcome criticism. I try to do my best. And I think I succeeded last semester, and you can ask your friends too. I work with you. As long as you want to succeed, I make sure that happens, and I do my best to respect your wishes. As I said, I'm going to post your homework sooner. And, again, I was like writing multiple versions before, and kind of like I have my other class too. And then I have like tutoring with some of you individually and also with the class. So it takes me like longer to do things. So anyway, so now let's talk about this question that I wrote last session. So can anyone, so the questions that I give you in the exam, whether I talk in the sense of moles or grams, and depending on what I talk about, you do the calculations based on that. So in this example, I gave you, I said that this amount of, these grams of, if I ask you what is the name of this, what is it? Can anyone help me to write this name? So Cu is copper, right? So remember, dioxide we used for molecular compounds, right? For what type of compound this is? Ionic, right? Because we have metal, non-metal. And can anyone tell me what was the charge of oxygen? 2 minus, right? And because it is non-metal, it takes 2 electrons. And we have 1 of that, right? So what should be the charge of copper? So if we have plus 1, that is multiplied by 2, it would be plus 2. So it would be copper 1 oxide, right? And the other way to say that, it was like Cu plus O2 minus, and we switch these guys, right? Cu2O, okay. And then in some of your homework problems, I just wrote the equation. I told you that copper 1 oxide, or like solid copper 1 oxide reacts with carbon, or like solid carbon, and produces solid copper and carbon monoxide. So you should be able to write this equation if I give the description, right? Because I expect you to know how to write these compounds. And in the tutoring sessions that I just listed, I'm going to talk in more detail, review these parts of the materials. Okay, so going back to the problem that we're solving, I gave you this equation, and I told you that we have this many grams of, Cu2O, this many grams of carbon that produces this much of copper. And here, I didn't give you any information about carbon monoxide. So you don't have to worry about carbon monoxide as your product. So here, we're talking about copper as our yield. And yield, again, is your product. So if I ask you, what is the actual yield in this reaction? What is it?
87.4 grams.
Exactly, because this is the actual amount of copper that is being produced. So you don't even need to do any calculation, okay? Actual yield is this number, okay? And then percent yield, we said that actual yield is always lower than theoretical yield, and then you write it in numerator. So this is the formula for that. But to find theoretical yield, you should do calculations. And can anyone tell me what was the process of doing so? How can I find theoretical yield or limiting reactant? Yes?
You take the smallest number and divide all by it. So if you make carbon 1,
Uh-huh.
you can divide it by 1.5 and divide the others by 1.5.
Yes. So, yeah, our systematic way of that is to assume, each of them, if they were limiting reactant, right? If we consider Cu2O being limiting reactant, we calculate the amount of product that can be produced, and we do the same for carbon here, and then compare the numbers, see which one is less. That would be our theoretical yield. The reactant that is producing that would be limiting reactant. What I mean is that here I write how many grams, again, because we have like grams here, we calculate grams. If I give you moles, we calculate mole, okay? So you say how many grams of Cu, because that is the product that we're talking about, equals 114.5 grams of Cu2O. Okay? Are you following me? And then how can I convert, so I want to go from like Cu2O to Cu. How can I do this conversion? remember in chemical reactions, we should first convert grams to moles, and then moles to moles with the coefficients of a balanced chemical equation, and then moles to grams with molar mass. Okay, so what we do is that we write grams of Cu2O, we convert that to moles. Okay, so this is the first step. 99% of the time, almost to all problems that we encounter here, we convert grams to moles. That is the first step. Okay, and can anyone tell me how can I find the answer? So write this ratio. What should I use?
Molar mass.
Molar mass. Exactly. So Cu2O. We would say we have like 2 copper atoms plus 1 oxygen, right? And we go to periodic table, and I already did that here to be faster. And I had like so many questions to solve for you all, but we were talking for like 20 minutes, so I try to to solve as many as I can, and then I post the solutions for the ones that I don't have time to go through. And then oxygen is 16, right? We look at the periodic table atomic masses, which are the same as molar masses. And then we substitute these numbers here, 3.55, 16. When we do the math, where did I write that? Cu2O would be 143.1 grams per mole. It means that 1 mole of this compound has the mass of 143.1. Are we good so far? So we use molar mass to convert grams to moles. Now I should convert moles of Cu2O to moles of copper. This is what I want, right? And for writing this ratio, I look at these coefficients in a balanced chemical equation. Okay? So here for 1, and these are moles, 1 mole of Cu2O reacts with 1 mole of carbon, gives me 2 moles of copper, 1 mole of CO. So here for 1 mole of Cu, I have 1 mole of Cu2O. Does this ratio make sense to everyone? Okay. Now, I don't want moles of Cu, I want grams. How can I convert moles to grams? And again, I write this somehow that this cancels out with this. How can I write this? Molar mass, right? Or atomic mass, which numerically are the same. So it tells me that 1 mole of Cu has the mass of 63.55. Okay? Does this make sense to everyone? Yes?
Sorry, I actually spoke up earlier. I would have thought there would be 2 moles of copper on top instead of just the 1 on
Oh,
top.
yes, yes. So I just made a, yeah, I just saw wrong. Yes. Perfect. Thank you for telling us. Great catch. So, yeah, so here, this is Cu. So we have 2 moles of that. Okay. Let me check. Okay. Thank you. So now that equals, and I did the math at home, it would be 101.6977, which would be roughly 109.70 grams of Cu. So remember, this is the calculation corresponds to this part, right? So considering how much product, how much Cu we can have if we have 114.5 grams of Cu2O. Now we do the same thing with carbon. We say how many grams of Cu can be generated from 11.5 grams of carbon here, okay? So now I should convert grams. If you learned how to write the above one, the below one would be the same, converting grams to moles by molar mass, converting moles of C to moles of Cu by coefficients in a balanced chemical equation, and then converting moles of Cu to grams of Cu, again by molar mass. Can anyone tell me, if I give you this, that for carbon the molar mass is 12.01, what is this ratio?
1/12.01.
Thank you, yes. Because this is like this much gram per moles, it means that 1 mole of carbon has the mass of 12.01. What is this ratio? You have the equation here. At this point, it's kind of like messed up, but hopefully you can see the coefficients right. Exactly, 2/1. What is this one? Yes, 63.55/1, right? Because this is molar mass of copper. Does that make sense to everyone? If you learn this, all the questions would be similar. Converting grams to moles by molar mass, mole to mole by the balanced chemical equation, and the moles to grams with molar mass. And when you do that, if I can just manage to, okay, write this. That would be 121.70 grams of Cu. Can anyone tell me between these two numbers, which one would be my theoretical yield? The purple one or like blue one? Which one? So why? So what was theoretical yield?
The maximum amount with the amount of eliminated reagents that you have.
Yes. So this is actually a really good point, because we say maximum amount and you might be tempted to choose this one because this is more. But if I tell you, let me go back to do the calculations, whichever is less is your theoretical yield. Because you don't have enough reactants to do this one. Does that make sense? If you do the pancake analogy, even if on exam you were hesitant, just remember the pancake analogy that I told you. Even if you want to make more, you don't have the ingredients. So the maximum amount of products is actually the lower number when you calculate. So knowing that this is your theoretical yield, what is your limiting reactant? So this one, right? The reactant that leads to theoretical yield. So in that case, it would be Cu2O, right? Does that make sense? So the lower number here would be your theoretical yield. The reactant that leads to theoretical yield, like the egg example, right? Egg, limited number of eggs, limited the production of pancakes, so that is limiting reactant. So here you do the calculation, choose the lowest number, you say that is theoretical yield, and the reactant leading to theoretical yield would be your limiting reactant, okay? Whew. So now, how can I calculate percent yield? We already talked about, at this point it is like so crowded here, but hopefully you can see the actual yield. It's a number that I always give you because you should know that you cannot know the actual yield if I don't give you. It's kind of like a pancake example. I say, how many pancakes did I make? You say, I don't know. Maybe you didn't make any, maybe you burned them, maybe you threw them away, I don't know. So actual yield I should give you in the problem statement. And then you put it in the numerator because that's a smaller number, right? And then the theoretical is always higher. So you just, from the next part of the question, you just like substitute these values. And I'm going to write it as nice as I can here. Percent yield would be actual divided by theoretical. So it would be like 87.4 that I gave you in the problem statement. And then the theoretical yield was 101.70 here, right? Multiplied by 100%, which would be 85.94%. And this number should be less than 100%. So if I give you like 150%, you know that is wrong. Because the percentage cannot be more, or at least in our context, it cannot be. Because always the actual yield is lower. Any question with this? Good? Okay. In question, let me go to the next question. And I asked you similar question in your quiz. So it says sulfur in solid state. So I expect you to refer to the periodic table, be able to write sulfur, which is S. And I say in solid state, I expect you to write S in parentheses, meaning that it's solid. And fluorine in gas state, I expect you to know that fluorine is a diatomic molecule, is F2. Remember your halogens, F2, Cl2, Br2, I2. Oxygen, O2, nitrogen, N2, hydrogen, H2. These are diatomic molecules. So when I say fluorine, you should be able to identify that is F2. In gas state, right? React to form gaseous sulfur, meaning that, sulfur hexafluoride. And I expect you to be able to write sulfur hexafluoride. What would that be?
SF6.
Exactly. What type of compound it is? So it is gas, yes, but is it ionic or molecular? Molecular. You don't see any metal, right? And gaseous, it means that it is gas. Are we good with writing this? Good. And I say, how many moles of fluorine molecules are required to react completely with this much of sulfur? First step for us is to balance this chemical equation. Remember, if you don't balance, you cannot do any calculations. First, we should balance this equation. So for this question, it's fairly simple. You just have two elements. So S is like 1 in both sides. Here you have 6 fluorine atoms. How can I make this one 6? 3, right. And then remember, we only change coefficients, not subscripts. Because if I change F2 to F3 or F6, it won't be the same molecule. We just change the coefficients. So now this is balanced. After you balance the chemical equation, you can do your calculations. So let me read the question again. So I said, how many moles of fluorine molecules are required? So this one, I want to see how many moles of fluorine molecules are required to react completely with 2.55 moles of sulfur. So again, for all your questions, the thing that you want to find, you write how many moles of F2 required to produce 2.55 moles of sulfur. How can I convert moles of sulfur to moles of F2? Anyone? So molar mass has the unit of grams per moles. So it relates grams and moles, right? But do I want to convert mole to gram? No, right? So I don't need to use molar mass. But how can I do this conversion? Yes?
You could use the coefficient, so I think it'd be 1 mole of sulfur on the bottom and then 3 moles of F2 on top.
Exactly. So we used the coefficients in a balanced chemical equation. So here for 1 mole of S, I have 3 moles of F2. Okay. Does that make sense? Any questions? And then when I do the math, it would be 7.65 moles of F2. Okay, any questions? Okay, now let me try to start the next question. Or let's just. So sodium in solid phase, let me write another color. Sodium in solid phase reacts with fluorine in gas phase to form solid sodium fluoride. Again, I expect you to know how to write sodium fluoride. So Na would be Na plus, fluoride would be F minus. So that's why we call this, if you switch like these ones here, it would be NaF, right? Would be solid sodium fluoride. Okay? But what is wrong with this equation as I just wrote it like this? Can I just start doing my calculations with this equation? We should balance it, right? So how can I balance this? Anyone? Yes?
Make it so the sodium has 2.
Okay.
So then when you go to the next step, it reacts, they're both 1.
Yes, so basically what your friend did is that you have Na here, 1, 1. So if I put half here, would be 1 fluorine, 1, here. And then we multiply everything by 2. So this would be like this, right? But your friend just said, put 2 here and then put 2 here. So if you can just do it immediately, that's fine too, as long as you can write this. Okay, and now we write the question. We say, what mass of sodium fluoride forms from the complete reaction of 12.5 grams of fluorine molecule with enough sodium to completely react with it? So here, we assume that we have enough, and the reason your book frames these questions like this is that you may say, what if we don't have any sodium? We don't have any product, right? And that is a valid argument. So for that matter, in these type of questions, we say, okay, imagine we have everything we need. Just write the conversion factor here, okay? So what you do, and here, as I said, I post the solutions on Canvas, make sure to include those in the slides. For here, you say how many grams of NaF equals 12.5 grams of F2. And then you convert grams of F2 to moles of F2 by molar mass. You convert moles of F2 to moles of NaF by a balanced chemical reaction. And then you convert moles of NaF to grams of NaF, again, by molar mass. Does that make sense? And I also had another question here, and these type of reactions, we just assume that these are the coefficients in a balanced chemical reaction, and we don't care about what species they are. We call these generic reactions. And you should and then in these type of questions, I don't give you grams because we don't know the constituent elements, right? You don't know, but you can do still mole calculations. So as I said, I'm going to post a solution to these questions and also this question on Canvas, and we just do the attendance and call it decision. So your homework 11 is due tonight. Make sure to do that, and don't put it for the last hour, because if technical difficulty happens or whatever, I'm going to tell you that you had from weekend to do the homework. So just start early to make sure that you get it done. Yes?
The form doesn't give you a thing to put your name on it. It just gives you answer questions, one option, submit.
Oh, really?
Yeah.
Okay, so if the form doesn't work, don't worry about it.